Welcome you all. Today we are going to see chopper, which comes under the subject title Power Electronics and Drives. Its subject code is 18 EIC 305D. What is chopper? Chopper is a converter which can convert a fixed DC supply to a variable DC supply. The block diagram shows here is AC supply first has to be converted to an rectifier, so which is to be uncontrolled diode rectifier, and then it is given to a filter capacitor where the ripple voltages and noises are removed, and this DC unregulated voltage will then given to a chopper which is called as a DC to DC converter, and with the help of the controlling voltage the regulated DC output voltage is obtained, which can be connected to the load. The methods of control. The output DC voltage can be verified by the following methods: constant frequency control or pulse width modulation control, variable frequency control, or the first one, the pulse width modulation. In pulse width modulation, the pulse width T on of the output waveform is varied, keeping chopping frequency f, and hence the chopping period T is constant. Therefore, the output voltage is varied by varying the on time T on, and it shows the output voltage waveform for the different on times. Variable frequency control. In this method of control, the chopping frequency f is varied, keeping either T on or T off constant. This method is also known as frequency modulation. In frequency modulation, to obtain the full output voltage, the range of frequency has to be varied over a wide range. This method produces harmonic in the output, and for large T off period, load current may be discontinuous. Basic DC to DC converters are of different types. The first one, buck converter, which is called as a step down converter. The other one, boost converter, which is called as step up converter, and the other one, step down or step up converter, which is called as buck boost converter, and last one is cuck converter. So this block diagram shows that DC supply is taken either from the rectifier, or it can be a filter, or it can be battery, fuel cell, etc., which can be given to a chopper, which gives you a DC regulated output and then given to a load. Buck converter. This circuit diagram shows with a DC supply voltage with a switch S and diode D, and the inductor which has an voltage of cross VL, and the capacitor and the load resistor R. So we are going to analyze this buck converter with the two different modes. The one is mode on, when the switch is on period, and second one, the switch is off period. When the switch is on, what happens? So when the switch is in on condition, the diode will get a reverse bias and the diode will go to an off state. So when supply voltage will crosses the switch and then to the inductor, and then to the capacitor and to the load resistor. So the current flow will be Vn switch and then VL and then capacitor and to the resistor. So this can be written as an equation. The voltage across the capacitance in steady state is equal to the output voltage. So let us say the switch is on for a time period T on and it is off for a time period T off. We define the time period T, total time period T, as a T is equal to T on plus T off. So the switching frequency can be said as F is equal to 1 by T. So the duty ratio or duty cycle can be defined as T is equal to T on by T. So by using the KVL in the switch mode on period, V in can be written as VL plus V naught. VL is nothing but L into DIL by dt, and when you substituting this VL in the equation, it becomes DIL by dt is equal to V in minus V naught by L. So this del IL can be written as del IL of closed period, which will be equal to Vin minus V naught by L into dt. dt is nothing but the time period del t. So when the mode switches off period, what happens to the circuit is the diode will become the forward bias. So now the charged inductor will be discharging to the capacitor and to the resistor. So the circuit will be, the energy stored in the inductor will be released and is ultimately dissipated to the load resistor, and which helps to maintain the flow of current through the load. But for the analysis, we keep the original convention to analyze the circuit using the KVL. So by applying the KVL to the circuit, V in is equal to VL plus Vc, where the V in is 0 now. So 0 is equal to VL plus V naught. So VL is written as L DIL by dt. So when you are substituting this VL in the above equation, we get VIL is equal to minus V naught. So substituting del IL as an IL and del T as in 1 minus d into T, the equation will become del IL is equal to minus V naught by L into 1 minus d into T. So, this can be written as the net charge changing of the inductor current over any one complete cycle will be equated to 0. So, del IL in the closed time period plus the del IL in the open period will be equated to 0. Substituting the above equation, we get the final equation as V naught by Vn is equal to D. Next one is boost converter. In the boost converter, the supply voltage, the inductor and the switch will be placed across the supply voltage and the load, and then the diode, capacitor and the load resistor. The V naught will be called as a load resistor. So, the design analysis will be consist of two modes. The first mode, when the switch is on, what happens? So, switch is on, the diode will become reverse bias, and therefore it represents a short circuit, ideally offering the zero resistance to the flow of current. So, when the switch is on, all the current will be flowing through the switch and back to the DC input source. So, let us say that the switch is on for a time period T on and it is off for a period of T off. So, we define the total time period T is equal to T on plus T off, and the switching frequency F is equal to 1 by T. So, now duty cycle is defined as T on upon T. So, now using the KVL to the circuit, Vin is equal to VL. Substituting VL is equal to L into DIL by dt, we get the equation as DIL by dt is equal to VIL by L. Substituting this DIL as del IL and substituting the del T as dt, we get the final equation as del IL is equal to Vn by L into dt. So, now we are analyzing the mode 2 when the switch is in off state. So, when the switch is in off state, diode will be forward bias. So, in this mode, the polarity of the inductor is reversed. The energy stored in the inductor is released and is ultimately dissipated in the load resistance, and this helps to maintain the flow of current in the same direction through the load, and also step up the output voltage as the inductor is now acting as a source in conjunction with the input source. But for analysis, we keep the original convention to analyze the circuit using KVL. So, applying the KVL to the circuit, Vin is equal to VL plus V naught. VL is substituted as L into DL by dt. So, now the equation will become DIL by dt is equal to Vin minus V naught by L. Substituting the dt as the T off period, that is 1 minus d into T, the final equation will becomes del IL is equal to Vin minus V naught by L into 1 minus d into T. So, substituting both the current during the on condition and off condition to equating to 0, the final equation will be the V naught by Vn is equal to 1 upon 1 minus d. So, the application of chopper is to use to control DC motors in the power range from a few watts to hundreds of kilowatts in switch mode power supplies to stabilize the low DC voltages in measurement circuits, etc. Important application includes converting an available DC voltage to a lower or a higher value. This application is especially common in switch mode power supplies. And second application can be a controlling of DC motor, where the motor supply is a DC source. Thank you all.